In part 2, we are going to be using more rules, more multiplication properties of exponents, and this time we're going to be raising a power to a power. So let's see what that rule is. So taking a look at the first problem here, we have 3 to the second, but it's raised to the third power. So if we were to rewrite this in a different way, it would be the same thing as saying 3 squared times 3 squared times 3 squared. You see, we're taking 3 squared and we're raising that to the third power. Well, the rule then would say, as we learned in the last stage, it would be, since things are being multiplied, we'd add up those exponents. 2 plus 2 plus 2 would end up being a total of 6 altogether. Well, there's a faster way to do that, and that is to see that here we have two threes being multiplied, but we've got 3 groups of that. See, 1, 2, 3 groups. And the rule is, since we are repeating addition, we could multiply the exponents. So we can multiply these exponents only when we have a power raised to a power. See, 2 times 3. 3 groups of 2 gives us the same answer, 3 to the 6th power. We're going to be using that concept of multiplying exponents when we have groups of repeated addition. So the rule, though, one of the big rules is to remember to raise everything to a power that's in parentheses that has a power on the outside. So for instance, this 2 here is really just 2 to the first power. So if I was to rewrite this out, this would be 2x squared times by 2x squared times by 2x squared. So notice how this 2 is to the first power, so when I use that rule of thinking about how many groups of 1 I have, see, I have 1, 2, 1, 2, and 1, 2 makes 3 2's, all being multiplied together. So when I write this out, it's 2 to the first power times by 3. 1 times by 3 is going to give me 3. And then I do the same thing here. Here I have 3 groups of x squared. 1, 2, 3 groups of x squared. So I could rewrite that as x squared times by 3 because there's 3 groups of 2. So when I go ahead and multiply this stuff out, I get 2 to the third, x to the 6th. And then if the numbers are small enough, go ahead and multiply them out. 2 to the third makes 8. So 8x to the 6th power would be the answer. So the rule is, if you're going to use that rule, you've got to make sure that you put an exponent on each of the terms inside the parentheses. So the common mistake is people want to multiply 3 times by 2 because they think of the distributive property. But that would be wrong. Notice that it's not 2 groups of 3 being added together, but 2 times 2 times 2. So we're multiplying a series of 2's together. That's why it's 2 to the third power. Well, same thing here. If this is a negative 2 inside parentheses, times by x to the 4th, treat that as negative 2 to the first power. Same thing over here. 3x squared is same thing is 3 to the first power times x squared all to the second. And so if we use those rules, this is what we get. We have a negative 2. Notice that it's in parentheses to start with, so I'm going to write it in parentheses to the first times by 3. And do it the same thing over here, because this would be 3 groups of negative 2 being multiplied. And so over here I have x to the 4th. Now I have 3 groups of x to the 4th. So that's 4 times by 3. Over here I have 3 to the 1st times by 2, because I have 2 groups of 3. And then over here I have 2 groups of 2, so it's 2 times by 2. And so it's only multiplication when the exponent is right outside the parentheses. That means groups of what is inside the parentheses. So this makes a negative 2 all to that third power, x to the 12th power. Here I have a 3 to the second power, and I have an x to the 4th. So here we'll go ahead and multiply out some of these numbers, and then also I will end up combining as well eventually. So here we have now negative 2, negative 2, negative 2. So that makes 3 negatives. So that's why it's a negative 8, x to the 12th. And then I'll go ahead and count up the number of x's. So I've got 4 x's here. And then I have 3 squared, which just makes 9. So now I can go ahead and multiply out those two numbers, those coefficients, because now I can multiply them because they just have an exponent of 1. You can't combine them unless you go ahead and take the exponents first. Remember, that's what order of operations said. So our final answer would be negative 72x to the 16th power. Notice I'm not taking the reciprocal of that negative 72 because it's only negative exponents that we take the reciprocal of. Well, this one's a little different. We've got a minus sign on the outside, which just means negative 1 times by what's inside. So let's first go ahead and clear this parenthesis by taking 3 groups of whatever's inside. So we still have the negative 1 times by 2 to the 3rd power. And then multiply out these exponents. X squared times 3 makes x to the 6th power. And then over here, this is a negative 2 in parentheses. So I'm going to rewrite that in parentheses, negative 2 all to the 4th power. So it's 4 negative 2's being multiplied. And then count up the x's here. So we have x to the negative 3rd all to the 4th. So that means we have 4 groups of negative 3. So that would be x to the negative 12th power. So we go ahead and do the exponents first on those numbers that we can multiply, and we go ahead and get a negative 1 times by 8. So 2 to the 3rd was 2 times 2 times 2. That's how I'm getting 8. And then over here, let's go ahead and bring this one over. And so I've got a negative 2 to the 4th. So it's 4 negatives. So it's going to end up making a positive. So that's why I end up with a positive 16. So negative 2, negative 2, negative 2, negative 2 makes 16. And then let's count up the x's. Here I have x to the 6th plus negative 12. And so I can go ahead and multiply out these numbers. This is a negative times 2 positives makes a negative, and it's going to be 128 when you multiply 8 and 16. And then count up the x's. We have x to the negative 6th because I had to subtract those exponents because they're opposite in sign. Well, when I do that, I end up with a negative exponent. So here's where we're going to go ahead and take the reciprocal. Notice the negative 128 staying where it's at. So my answer is negative 128 over x to the 6th power. There is our answer. Well, another one here. We have to clear just 1 in this case. See, there's no outside exponent on these. So I'm just going to take these two terms right here, and I'm going to bring them together. X squared and a 3 as well. Now let's go ahead and clear that parenthesis with the exponent on the outside. So again, we'll treat this as 3 to the 1st power, and we'll go ahead and think of 3 groups of 1. So this is going to be 3 to the negative 3rd power because we have the opposite of 3 groups to the 1st. And then we have the opposite of 3 groups of x squared, so that's going to end up giving us an x to the negative 6. Notice when you multiply a negative and a positive, you get a negative. Well, we go ahead and do some work here. We can count up the exponents. Now, don't multiply out these 3's until you get rid of those negative exponents. So combine everything first. Leave this where it's at. And so we'll go ahead and add up those exponents on the x. We end up with an x to the 5th. And we can go ahead and add up the negative 6 here. I end up with negative 6. And then I still have this 3 to the negative 3rd power. And so from there I end up with an x to the negative 1st. And it's a 3 to the negative 3rd. And so we go ahead and do some work there. And now we can go ahead and take any exponent that's negative and switch it. So don't multiply out numbers until we have positive exponents. And so what's left here is a 3 or a 1 over 3 to the 3rd x to the 1st. And so a common mistake is people want to go ahead and multiply out these 3's and just call it negative 27, but that's not the case. Always take the reciprocal first, then multiply out the numbers. And so what's left over? Well, we've got a 1 on top. We've got 27x to the 1st power, or just 27x on the bottom. And there's our answer. So another problem to try. It's got a similar situation where we have some parts that are being multiplied, but they don't have that outside exponent. So it's just the ones with the outside exponent that we have to concern ourselves with. So all these numbers here, they're just being multiplied, you can bring together. So I got this 2, the negative 4, but I can't bring this 2 over because I need to get these exponents dealt with first. So here I have an x to the second and to the fourth, so I can add those together, 2 plus 4. So I've just dealt with these two to start with, and that stuff's down here. Now let's go ahead and deal with this. So 2, but it's 3 groups of it, so it's 2 to the third power. X, but 3 groups of it makes x to the third power. So we multiplied these exponents here. So now we can go ahead and get rid of these exponents by multiplying all this stuff. And this gives me 8. So let me rewrite what I've got here. 2 times by negative 4. I'll add this stuff up, and I'll go ahead and bring this 2 to the third over. This makes 8 now. 2 to the third is 2 times 2 times 2. And we have an x to the sixth power, and then we also have this x to the third power. They're the same base, so I can add them together. Well, we go ahead and multiply out these numbers. We get a negative 8 times by 8 makes negative 64. And then we have x to the ninth power. And there is our answer. So key is, don't bring everything together first until you get rid of those exponents. The rule is that you have to take exponents before you multiply. Well, 2 more problems here. This one's a little bit more difficult. Seems like a little bigger problem. And so we, again, if you see an exponent on the outside, you don't see exponents inside, always put 1 there. And then you multiply the exponents. So it's 2 to the negative fourth. So the opposite of 4 groups of 2 is 2 to the negative fourth. Here we multiply these exponents. The opposite of 3 is positive, so that makes x to the 12th power. And then we have a y to the negative 4th power. See, opposite of 4 groups of 1. Over here we have another outside exponent, so don't see exponents on the number or the variables. Put 1, and then take the numbers, take the exponents. So it's 2 groups of 1, so it makes 3 squared. 2 groups of 1 again, so it makes x squared. So again, I'm multiplying these exponents. Over here, no outside exponents, so I just have a 5x and a y to the third. So that just all gets brought down. Now, I can go ahead and take the exponent on the coefficient and bring these together. Now, I can't multiply out the numbers because I got exponents there. So I'm just going to remember, if it has a negative exponent, don't multiply it out yet. It's just 2 to the negative fourth. And I'll just bring this 3 squared over and the 5 over. Bring those numbers next to each other. Can't combine them because they're different bases and they have exponents. You got to get rid of the exponents first. Now bring all the x's. X to the 12th. We've got a 2, so I'll add that on, and I got a 1. This one's a 1. And then I look at the y's. I've got y to the negative 4th, and I've got a y to the 3rd. So it makes 3. And then I go ahead and take those exponents, and I'm going to take the reciprocal, but let's go ahead and combine these first. All right, let's go ahead and leave this as 2 to the negative 4th, but I'm going to go ahead and multiply out the 3 and 3 since that makes 9. Now, again, I multiplied that out because it had positive exponents. Now bring this 5 down. I've got x to the 15th power and a y to the negative 1st. Now I'm dealt with all my exponents and the addition and whatnot, so now I'm going to go ahead and take the reciprocal. Take the reciprocal of just the negative exponents. They go on the bottom. See, these 2's, I didn't want to multiply them out until I put them on the bottom. And now let's go ahead and multiply out some numbers and see what's left over. So 9 and 5 make 45. And then I've got x to the 15th power. And then down below I've got this 2 to the 4th now makes 16. And I've got a y on the bottom. So notice I didn't multiply out those 2's until I brought them to the bottom of the fraction so that they became positive exponents. Well, one more problem here, and here we're going to take some exponents, write them out there. So if I don't see them, I'll put them out there as 1's and multiply those exponents. So 2 to the 3rd power, a to the 6th power, c to the 6th power. Do the same thing here. I've got 3 to the negative 2nd, a to the negative 6th, and a c to the positive 4th. And then just bring all the a's and c's together. So I still got that 2 to the 3rd, 3 to the negative 2nd, a to the 0 power, 6 and negative 6 makes 0 when I add them, and c to the 10th. Well, when I've got something like this, I take any negative exponents, take their reciprocal first, and then multiply them. And so when I do that, I have 2 to the third on top, which makes 8. Anything to the 0 power makes 1, and a c to the 10th on top. Now what's on the bottom? 3 squared. So when it becomes 3 squared, I can multiply that out, and that gives me 9. And there is my answer. Well, those are the problems you'll see on tonight's homework. Good luck.